The given question is an electron is an excited state of Li2 plus ion has angular momentum 3h over 2 pi. The de Broglie wavelength of the electron in this state is p pi a naught, where a naught is the Bohr's radius. The value of p is, so these are the given options: p equals to 2, p equals to 4, p equals to 1, and p equal to 3. So now we are given the angular momentum of the Li plus 2, that is 3h by 2 pi. So we know that L is given as the integral multiple of h over 2 pi, right? And it is given equals to 3h over 2 pi. So if I compare these two equations, we can get n equals to 3. Okay, so let it be equation 1. Now further we can write L equals to mv into r. Okay, that is equals to nh over 2 pi. Okay, so further we have to find the lambda first. Okay, de Broglie wavelength. So de Broglie wavelength is given as h over p, where p is the momentum. Also I can write as momentum is given as the product of mass into velocity. So I can write the value of mv equals to h over lambda. So now I can replace here mv by h over lambda. Okay, so this is h over lambda into r equals to nh over 2 pi. So h will get cancelled out from here, and we will get lambda equals to 2 pi r over n. Okay, now we also know that r is given as Rn is equals to n square a naught by z. Okay, where Rn is the radius of the nth orbit. Okay, so I can put the value here. So lambda will come out to be 2 pi over n multiplied by n square a naught by z. Okay, and z is the atomic number, right? So we are given, see, for Li plus 2 the atomic number would be 3. Okay, so here we can cancel out the value of n, and lambda we will get equals to 2 pi a naught into n over z. Okay, now from equation 1 we have n equal to 3, right? And z is equal to 3 for lithium, so we can write as 3 by 3. So this 3 and 3 will cancel out, and we will get lambda equals to 2 pi a naught. Okay, now we are given, see, in the question we are given the de Broglie wavelength lambda equals to p pi a naught. Okay, p pi a naught, and we have just found out the lambda is equals to 2 pi a naught. So by comparing these two equations, we will get p equals to 2. So this is the required value of the p. So from the given options we have A, B, C and D. Option A is the correct answer. Thank you.
Hello dear students, here the question is: an alpha particle and proton are accelerated from rest by potential difference of 100 volt. After this, their de Broglie's wavelength are lambda alpha and lambda p respectively. Then the ratio of lambda p to lambda alpha to the nearest integer is. We know that the value of de Broglie's wavelength is calculated by the formula lambda equals to h upon p, and the value of kinetic energy is calculated by the formula 1 by 2 mv square. Now multiplying numerator and denominator by m, it will be 1 by 2 m square v square divided by m. But we know that mass into velocity is nothing but linear momentum. Therefore m square v square will be equal to p square. That is, the value of kinetic energy is 1 by 2 p square divided by m. This is the formula of kinetic energy in terms of linear momentum. Therefore p square will be equal to twice m into kinetic energy. Now taking square root, p will be equal to root of twice m into kinetic energy. Now putting this value in equation number 1, we get the value of de Broglie's wavelength lambda will be equal to h upon root of twice m into kinetic energy. but the loss in kinetic energy will be equal to the gain in potential energy. Therefore kinetic energy will be equal to potential energy, that is Q into V. Hence the value of de Broglie's wavelength can also be written as lambda equals to h divided by root of twice m Q into V. Now the de Broglie's wavelength associated with the proton will be equal to h divided by root of twice mass of proton into charge on proton into potential. Similarly, the value of wavelength associated with the alpha particle is calculated by the formula h divided by root of twice mass of alpha particle into charge on alpha particle into potential. Therefore, lambda p divided by lambda alpha will be equal to h divided by root of twice mp qp into v divided by wavelength associated with the alpha particle is h divided by root of twice m alpha q alpha into v. Now on solving this we get h divided by root of twice mp qp into v multiplied by root of twice m alpha q alpha into v divided by h. Now same term will get cancelled, that is h will get cancelled, this 2 root 2 will get cancelled, this root v will get cancelled, and therefore wavelength associated with proton divided by wavelength associated with the alpha particle will be equal to root of mass of alpha particle into charge on alpha particle divided by mass of proton into charge on proton. But mass of alpha particle is 4 times the mass of proton and charge on alpha particle is twice the charge on proton. Putting these values in equation number 2, we get wavelength associated with proton divided by wavelength associated with alpha particle equals to root of 4 into 2, that is 8 mass of proton into charge on proton divided by mass of proton into charge on proton. Now same terms will get cancelled, therefore the ratio will be equal to root of 8, which is approximately equal to 3. I hope this has answered your question. Thank you.
Hello friends, let's see this question. The wavelength of K alpha X-rays produced by an X-rays tube is 0.76 angstrom. The atomic number of the anode material of the tube is option A 20, option B 60, option C 41 and option D 80. So in this question we have a X-rays, okay, the K alpha X-rays, and which is produced by an X-rays having the wavelength is 0.76 angstrom and K alpha is the line, okay. The atomic number of the anode material, we have to find atomic number of anode material of this tube, okay. So first of all write the given data. The given data is the wavelength. So wavelength of alpha is 0.76 angstrom, which can be written as 0.76 into 10 to the power minus 10 meter, because 1 angstrom is equal to 10 to the minus 10 meter, okay. And now we have to put a formula of this Rydberg constant formula, like using the formula we can get, this is Rydberg equation, okay. So according to Rydberg, this is not Rydberg, this is Rydberg, okay. This is Rydberg equation in term of Mosley's law, we can write the formula as 1 by lambda of A is equal to 3 by 4 into R Z minus 1 to the power square. Okay, so this is the formula where lambda is given. R is the Rydberg constant whose value is also we know 1.097 into 10 to the power 7. So we have to find the value of Z here. Okay, so solve this, we get 1 upon lambda. The value of lambda is 0.76 into 10 to the power minus of 10 is equal to 3 by 4 into R, the Rydberg constant. The value of Rydberg constant is 1.097 into 10 to the power 7, and this is Z minus 1 square. So for solving this, we get Z minus 1 square is approximately equal to 1600. That means Z minus 1 is equal to 4, that is 40. Okay, so Z is equal to 40 plus 1, which is 41. Hence option C is correct. Hence we can say option C is correct, that is 41. So the atomic number of anode material of the tube will be 41. So we can say hence option, which option is correct? Option C is correct. So option C is correct. I hope you have understood the solution. Thank you and keep watching.
इस क्वेश्चन में हम बोल रहे कि एक्स-रे ट्यूब का एक्रॉस में यानी एजेस में 20 किलोवोल्ट्स ऑफ पोटेंशियल डिफरेंस अप्लाई किया गया है। अब हमें कैलकुलेट करने के लिए पूछ रहे मिनिमम वेवलेंथ कितना है उसका। सो हमें पता है E इज इक्वल्स टू एच सी बाई लैम्डा, E इज इक्वल्स टू एच सी बाई लैम्डा और पोटेंशियल एनर्जी इज इक्वल्स टू एच सी बाई लैम्डा। यानी इधर एनर्जी दिया था 20 किलोवोल्ट्स दिया था, ये किलोवोल्ट्स में, तो इसको वाट्स में कन्वर्ट करेगा तो ये क्या हो जाएगा 20,000 वाट्स हो जाएगा। हमें कैलकुलेट करने के लिए पूछ रहे इधर लैम्डा का वैल्यू कितना है। इधर ये लैम्डा का वैल्यू हमें फाइंड आउट करने के लिए पूछ रहे क्योंकि लैम्डा है वेवलेंथ, देयरफॉर लैम्डा क्या हो जाएगा यानी वेवलेंथ क्या हो जाएगा hc/e हो जाएगा। हमें पता है h इंटू सी का वैल्यू है 1240 एंड e का वैल्यू है 20,000 वोल्ट्स है, 20,000 वोल्ट्स है। सो इसको कैलकुलेट करेगा तो हमें वेवलेंथ का वैल्यू निकलेगा 62 इंटू 10 टू द पावर ऑफ -3 नैनोमीटर से, और लैम्डा इज इक्वल्स टू 0.62 एंगस्ट्रॉन्स। देयरफॉर हमारा आंसर है 0.62 एंगस्ट्रॉन्स।